When we go to the magnification levels of in science, we find out there are much smaller things that are present in our world. When we start magnifying through a powerful microscope, we find out first things that are microorganisms, which include bacteria, viruses, etc. When we magnify more, we find out that there is a structure. This structure is known as the molecules. Molecules is the basic structure of any atom. This keeps any object binded with each other. Magnifying more can show us a vast universe of atoms. These are for now the most basic and the smallest particle that has been proven. But in our scientific community, there's a concept called quarks and quantum mechanics to be known the smallest particle to be recorded. But because of some scientific flaws, this theory was not accepted and this theory is being improved today. We'll talk about this in another video. So, coming back to atoms, atoms are the basic structure of anything. Atoms are divided into more subatomic particles, which is known as electrons, neutrons, and protons. Electron has a negative charge, proton with a positive charge, and neutron with a neutral charge. Electrons have their own orbit, and protons and neutrons are packed into a very small dense ball. The orbit of electron is also known as atomic orbitals.
Protons are positively charged particles which are present in the nucleus of the atom alongside neutrons. An atom is composed of protons, electrons, and neutrons. The entire mass of an atom is concentrated in the nucleus, which is at the center. When nucleus contains protons and neutrons, which are collectively called nucleons. Electron. Electrons are negatively charged particles of an atom. Together, all of the electrons of an atom create a negative charge that balances the positive charge of the protons in the atomic nucleus. Electrons are extremely small compared to all other parts of the atom. An atomic nucleus sits at the direct center of an atom. An atomic nucleus consists of positively charged particles called protons and uncharged particles called neutrons. An atom is composed of a positively charged nucleus and electrons revolving around it in defined circular objects. The nucleus is very small and dense when compared to the rest of the atom. It is about 10,000 times smaller than the rest of the atom.
Now let's learn about the history of atoms. The history of atoms is quite complicated with lots of models and theory. Democritus's theory of atoms presented us that all the matter, including space and time, was made up of small units known as atoms. He did numbers of experiments and had little evidence, but the idea was kept by many scientists in their other investigations. Ahead, Dalton also agreed that all matter was created by atoms, which he believed were indestructible. He also stated that compounds are created by combining two atoms and that all atoms of given elements are identical in their mass and properties. Then many scientists came and gave their theories. But afterwards, the main thing begins when J.J. Thomas discovered electrons, where he told that the atoms were like a plum pudding. This analogy told that J.J. Thomson's atom structure was like the plum pudding, where the electrons are embedded inside the positive charged cloud. Rutherford in 11 did not agree with the idea, as Rutherford did an experiment known as the gold foil experiment. Here, Rutherford already know that the particle with positive charge repel positive charged particles, and alpha particle produced by radioactive elements would produce positive charged alpha particles. So, if the Plum model was correct, then the alpha particle would directly pass through the atoms. Here in the experiment, alpha particles were fired towards the fluorescent screen, which was made up of zinc sulfide. This fluorescent screen glow when the alpha particle hit them. When the gold foil was added between them, some of the particles were deflected, and the ratio of 1 to 12,000 particles were bounced back. So, technically, from every 12 particles, one particle bounced back. Here, the scientists concluded that the atoms are having a lot of free space, because while the experiment was happening, most of the particles were directly going through the gold foil. They also told that the atoms have a dense nucleus which is not at all easy to penetrate it. The nucleus was positively charged as the particles inside it were positive. Also, while the alpha particles were coming, the positive charged particles repelled the positive charged alpha particle. Due to this, they bounced back. So, according to him, the model should be shown here. This was a huge change from the previous models. In 1930s, Niels Bohr added some theory in it. He covered up the flaws of the structure of atom given by the Rutherford. He told the outer orbits in an atom could hold more electrons than the inner orbit. By knowing this, one can determine the atom's chemical properties. He also gave birth to the idea that electrons emit light by jumping orbits. Then, in 1932, finally the neutrons were discovered by James Chadwick. He got a Nobel Prize for this. Interesting facts. Hydrogen atoms can make any atom in the periodic table by just doing fusion process and fission process. And for example, stars are also known as carbon stars, as they form carbon in their core.